Welcome to TechFaithful. I'll be your presenter for today. My name is Azua, and today's topic is how the internet works. We'll be looking at the basic building blocks of the internet, how to connect to the internet, what protocols are followed on the internet, and where we're going when it comes to the internet. Most of us know the internet as a client sending and the client receiving, and the rest of the stuff in between is a mystery. So today we're going to dive deeper into that cloud, that mystery between the client on the sending end and the client on the receiving end. There are 6 categories you could look at regarding what it takes to set up the internet. But what is the internet anyway? The simplest definition of the internet is a network of networks. Okay, it's a network of many networks connecting one computer from one side or one area to another computer in another area. The client is normally what we all know, the device, and this could be a phone, could be a computer, could be a Tesla car, could be the camera, anything. And then we have the connection. Okay, and that's the connection between 2 points in a network. We have a signal, we have connecting devices, we have servers, we have software, and we take a look at these coming up. But before we go further, we'll see that this internet here is actually more of something like this, and this is still a simplification of it. What we need to appreciate in this diagram is that we have many connecting devices between 2 clients that are receiving the data, and most importantly we have one client that is connecting one router that is connecting the client to the internet, and that's called a gateway. The gateway works with a modem, okay, to connect to the internet, and we'll see why the modem is very important coming up next. But let's first take a look at what these blocks of the internet are all about. So a client could be a device, okay, hardware, software, using a server service. So like I mentioned before, your laptop is a client, your phone is a client, and so on and so forth. You could have these connected via air, okay, when you're using Wi-Fi. So your air, the air around you is your connection, or a DSL cable can be a connection, and so on and so forth. And the signal that's actually transferring the data, that energy that moves information from your phone to your home router, is called the signal. So that energy is called the signal, and we need a connecting device because usually distances between 2 points in a network are not that short. So usually you need a connecting device between them, and this device could be a hub, could be a router, could be a switch, and you're going to see what's the difference between these devices and why would you prefer one over the other. And always there is a server in a network, any network, that actually processes requests by other computers. That's a computer that could be a program or device that processes requests by other computers. So these requests could be for email, could be data your database, could be your web pages, and so on and so forth. And all these computers need rules on how to operate, instructions on what to do, how to behave, what do they serve, and so on and so forth. Now, all these instructions are captured in form of software. If we take a quick look at the connecting devices, the types, and when we need them, why one is useful over the other. Let's take a look at these three, okay, because they're the most commonly used connecting devices. In the order of how smart the device is, we take a look at the hub, and the hub, on receiving a signal, it broadcasts this signal to all the parts. All the parts receive the same signal. So as you can imagine, with a lot of data moving or being transferred by the signal to the hub, there will be too much noise for any of these parts to be very useful to the client, because the client will be receiving too much noise about data meant for other clients and can't process theirs more efficiently. So that's why the switch comes in. For the switch, each port is identified by a MAC address, and MAC is Media Access Control. It's not MAC as in Macintosh. It's Media Access Control, and this is used by the switch to identify which client to send the signal to. Okay, and when it sends the signal to the client, it never broadcasts to any other client, and this is very useful to prevent any noise that the hub was creating at the other parts. Now, on the other end of the spectrum is the router. The router uses IP addresses to tell which client to send the signal to, and because it's smart enough, it can be used to even transfer signals to other networks. Okay, how does it tell which signal to send where? Because it has a routing table. Okay, a router has a routing table, tells it the status of that IP address, whether the client is available, okay, or the client is busy, or the client doesn't exist anymore. Okay, IP address is dead. It knows all that because it keeps a log of all these parts, a table of all these parts, IP addresses rather, that are accessible by it, and this makes it very smart compared to the switch, where whether the client is down or not, the signal will still be sent to that MAC address, which is not very efficient if you are dealing with a lot of data or sensitive data, because you never know whether the data is passed efficiently or not. Of course, these devices are useful each in their own right, but that is a topic for discussion for another time. So let's quickly look at the modem. And a modem is really a short form for modulator demodulator. And modulator, as a modulator, it changes the format of the analog signal to a digital signal. Of course, this is a simplification because you have a lot of things involved in just the modulation or the demodulation. Okay, things like filtering, removal of errors, amplification, and so on and so forth. But that is again a topic for another time. And on the other side, as a demodulator, it changes a digital signal from your computer to an analog signal that can be sent over the media, the connection. So could be an electromagnetic wave, okay, that is going to be transferred to another device. For maybe if you're using Wi-Fi, could be converted from a digital signal to light to be transferred to another device if you're using optic fiber, and this device is replicated at the receiving terminal to do the same thing. So you have a modem at the sending and the modem at the receiving to handle the interpretation of the signal sent. Most common ways to connect to the internet, if you remember dial-up access, okay, most of us are used to this signal, okay.